All right, ladies and gentlemen, please welcome back once again Mark Peco on for another episode of Speaking of Data today. Mark has joined us a couple times in the past to talk about dimensional modeling and NoSQL, and I would encourage everyone to go back into the archives and take a listen to those. They were excellent episodes, and very happy to have Mark on today. We're going to talk about data modeling. And we're going to get into a lot of the ins and outs of the essentials of data modeling here on this episode. But it's also because Mark is going to be teaching a seminar for TDWI coming up in December. We'll get into that as well. But before we jump into all the questions, Mark, thank you so much for your time today. How are you today?
Oh, thanks a lot, Andrew. I'm doing very well. Thanks. Appreciate it. Thanks.
Absolutely. It's always a pleasure talking with you. So I do want to jump right into the topic here as far as data modeling is concerned. I think it's a topic that many folks that are listening might be familiar with, but for those that might not, can you start off with a baseline for us of what is data modeling and why it's important?
Sure. It goes back several years, and the term actually has evolved because, I mean, I worked on this type of work several decades ago, and data modeling had a very narrow kind of definition around designing a database. But with the advent of data science and analytics, data modeling has a much broader connotation, and people talk about the modeling of data, which you could say is part of machine learning. You could also say it's part of reporting and visualization. However, in the context I want to talk about here, it really is about understanding your data so you can design a proper kind of database to store it, anticipating a whole bunch of different kinds of use cases. So it's really about understanding your data and designing with all the different changes in technology today, the different ways we can organize and store it, depending on our priorities and goals for doing that.
Yeah, that makes a lot of sense. And I'm glad you brought up the data visualization piece there because, for me initially it was a little confusing as to like what the differences between the two of those are because it seems as though there is visualization components to data modeling. Can you maybe, specify a little bit of the differences there for us?
Sure. Let's think about data modeling in my kind of definition is it's to understand your data, understand how you want to organize it, and understand how you want to kind of store and provision it for others. Now, as part of that, the understanding is I might want to explore my data. I might need statistical visuals or profile it for quality or for different kinds of rules. So visualization might be a technique to understand your data, but also when we start to build and design databases, there are modeling techniques that are visual. So ways we draw diagrams of a database structure or data flows or data pipelines, we might use visuals to say the structure, flow, movement, and storage of data. So visualization is really, I guess it's a tool that enables the modeling to proceed.
Yeah, that makes sense. Thank you for taking us through that there. So, I mean, based on your explanation, this obviously seems very important for data and analytics professionals for all businesses here, really. But can you dive a little bit deeper as to why exactly it's relevant for both the IT and the business stakeholders?
Yes, I can. And part of the challenge here is people don't always appreciate why it's important because they sometimes think data modeling is a speed bump in their projects. It's a way to slow them down. The reality is we need to understand that the data is generated by the real world. So there's things in the real world, processes, things, events that generate data. So we have to understand those things if we want to organize the data in a flexible format. If people just stick data into a table like the big random blank spreadsheet and it's not organized based on a real world concept, the maintainability is really compromised because it's not structured according to how the world generated it. So part of the modeling is saying, what is the thing generating the data? Why do I care about that thing? And how do I organize the data around those things? And then because there's different kinds of database techniques today, there's many design principles to how to organize it physically. But first of all, we have to understand how do you want to organize it logically? Now, part of the problem here is people don't appreciate the business value of this because they say, well, I just want to get ahead and build something. Modeling is sometimes thought to be a thinking process, which it is. And people say, as a thinking process, are you busy? Are you doing work? And so thinking processes lay the groundwork for less issues and maintenance issues later, but you have to invest the time up front. Now you can time box that time, but sometimes people are not willing to spend the time. They just want to go build something. And that's the issue that eventually you might, because we can talk about short-term issues versus long-term issues. Modeling should help you minimize the long-term issues. which is around maintainability.
Yeah, I feel like that would be a relatively common thing that folks are, wanting to avoid, right? Any sort of slowing down process in the minds of these folks is going to be like, well, let's just avoid it. We'll kind of cross that bridge when we have to, kind of a deal. But it does make a lot of sense if you can cut out a lot of those problems before even getting started. So then, can you explain a little bit about what the data and the business capabilities that are enabled by using the data modeling?
Sure. Now, if you think about the data capabilities are around really data management principles. I'll come
Hmm.
back to that in a second. The business capabilities are the access and consumption of data to drive improvements and change and results in a business. So they have to intersect somewhere. So the data management principles are around, can I acquire the data? Can I define it? Can I store it for you? Can I secure it and protect it so it's used within the rules and guidelines we have to use it within? And is it organized in a way efficiently that minimizes our technology costs? So the whole principle of data management is to make it available to the right people at the right time. Those are all the technical data management processes. The business processes are, oh, can I now access that data? Do I know where it is? Do I know how to understand it? Is it in a form that deals with my problems? Is it relevant to me? And so if you don't model data, you'll never answer those questions. Are you storing the right data in the right way and protecting the right way? And answer the question, are people using the data that they need to solve their problems? And can they easily get at it? So these two worlds intersect. It's kind of like building infrastructure, like building a highway,
Hmm.
and then people are the drivers on the highway. So if you build the highway that's inappropriate to drive on it, you're not going to drive very well. So think of the people building the infrastructure are the data people, and the consumers of it are the drivers. We have to make these two worlds align.
Well, that was a very apt analogy there because my next question was going to be who's actually involved in the data modeling activity. So who are some of these people that are building the highways, if you so to speak?
Right. Now, because to answer that question, I have to go back and say there's more than one major activity within data modeling. Data
Mm,
modeling is really a spectrum of activities. So it goes back from understanding what do you need data for and why do you need it? That's a business analysis problem. And as you sort of scope and bound what data you need and why you need it, then you can start going into, well, how you want to organize it,
mm.
how you want to define it. So the whole you have to have stakeholders involved with analysts to understand what's needed and why it's needed. So people who are subject matter experts, who are business people, decision makers, have to commit time to be engaged to work with people who are trying to draw that out of their brains so we can define the scope and purpose, define a structure, pick the kind of database you want, and then implement it in a way that they can use it. If you simply don't get involved with that, then you'll never have the knowledge that's in your brain embedded into the models. And that's so important is commitment. I think of data modeling as a team sport for sure. It definitely crosses many parts of the organization that people have to become involved. And that's one of the big barriers. People don't want to spend the time, they want a solution, but they don't want to get involved with understanding the solution before it's built. That's a cultural issue we have to get across.
Hmm. Yeah, I feel like data strategy and having these, these kinds of things in place really helps with, the long term, like you're saying, maintenance and being able to eventually, create these different things that you want to accelerate whatever you're trying to get done in your specific business. But a
Right,
lot of that can be really helped with a strategy and taking the time out to, actually structure this thing and have an organized plan.
right.
So then, you talked a little bit about, I think, some of the phases or steps involved. I know there's more to it. Can you maybe take us through maybe a slightly elongated version of the different phases or steps involved in this process?
Sure. In one of the courses I'll be teaching in the seminar coming up in December, we talk about sort of a framework. And a framework is
Mm,
like a big checklist of things one could do to be totally rigorous and complete. And it breaks the activities into levels or layers of activities. And different kinds of people will be involved in those activities. So we start off with the idea of we sort of talk, what is the context? The context is scope and purpose. What data do you need? Why do you need it? That's a business analysis problem. We then get into then what's called the conceptual modeling, which is really the requirements.
mm.
If you have data bounded by a scope and purpose, the conceptual ideas are what questions does this have to answer? What decisions does it have to drive? How will this data be used to drive improvements? So that's really the requirements of the information once you've defined the scope and boundaries of it. Once you've got that in place, now you can start to consider how to organize it. And organizing we call logical modeling. Now, logical modeling is structuring the data around some principle that makes sense to you. Now, in most cases, we think of organizing around what's called an entity. An entity is a person, place, or thing. That's the real world object generating the data. So one of the common ways is organizing things around entities, the things we want to describe. And but we want to keep that independent of technology. So the logical models organize things in a way that makes sense to us because we want to be able to use this for long term. But there's many, many ways of implementing things today. Technology is rapidly changing. So
Hmm.
once we go from a logical model, we say, well, how do you want to implement this in database A, B, C, or D in the cloud or on premise? Because in the real world, there are relational databases, there are NoSQL graph databases, NoSQL document databases. There's stuff in the cloud like Google's BigQuery. All these things are out there. Now, how do you want to map your logical needs into those physical platforms? But the logical world is trying to be independent of the technology because that it connects closer to the real world, where the technology obviously connects to the volatile world of changing databases. So you're really trying to have that physical design. Once you've chosen your platform, then you need to implement it. So the final piece of the modeling is the implementation of this into real world, uh, call them database objects or database tables or structures, whatever you want to call them.
Hmm.
They're the ways you want to physically put the data into that environment, which now have to consider things like performance and security, and different kinds of ways to organize it to maximize the purpose of that data. So again, just to recap, it's contextual, which is scope and purpose. It's conceptual modeling, which is requirements. It's logical modeling to organize the structure somehow closer to the real world. It's then physical modeling based on the database you've chosen. And then it's implemented. We call it the implementation step at the end, which now, if we get it all right, you've got the right data for the right purpose and the right structure, and people can use it. And that's really the whole goal of all of this. Now, that seems like a long winded explanation, but these steps might be done by different people in different parts of the company, and they probably are. The real secret is to organize and coordinate across groups that share information because this needs to be a team sport, as I mentioned earlier. So this group gets this information,
Hmm.
pass it on to that information, and then we can apply it in a way that's consistent. So it's not a single team doing this normally. It's going to be some sort of a virtual team that has to coordinate their efforts.
Mm. Yeah, I think that was a very important piece there as well, but that was excellent explanation. I have a much clearer understanding of the process there. I don't know how easy or not this will be for you, but is there a way for you to maybe give a kind of a real world example of something like this? As far as a specific use case that you can recall? I know that it is a relatively common practice, but maybe it might help some of the audience members to hear, one specific example if you have one that you can pull out.
Okay, sure. Now, so if we think about a use case, first of all, again, we have to also categorize use cases because in
Right.
businesses, a core use case we might call operational, or we sometimes call them transactionally oriented. They're designed to build systems to, like order entry systems
Hmm.
or payment systems. They're not designed for analytics. So we commonly design data models. And back in the early days of my career, I was heavily involved in building a large system for a big energy company that was predominantly order management, pipeline scheduling, accounting, and it was very transactionally focused.
Hmm.
So the structure had to manage the things you needed to enter what was called a nomination, which was a transaction for ordering shipments of gas on a pipeline. And then it was really meant to have the business run. But if you're doing an analytical process, like you want to analyze trends, patterns, and do machine learning and data science, you might have a vastly different structure because you organize the data around analyzing it, not executing a transaction. And that's why we have data warehouses, because in
Hmm.
the early days that was thought to be the need of, but data warehouses have evolved to say there's many ways to do it because of technology. So if I think about an order entry system, and then you want to analyze orders, and you want to analyze fraud, you want to analyze, I don't know, customer service, customer behavior, you'd organize the data in a way to serve that problem as opposed to managing transactions.
Perfect. Thank you for that. I know I sometimes it's hard for me to even kind of wrap my head around the theories of it without having an explanation like that. So thank you so much. So I'm curious, what if any, what are the alternatives to carrying out data modeling?
Okay. It's the same thing if you want to build. anything. You want to build a house. You want to build something in your backyard. You want to build a shed. You want to build a deck. Do you have to design and plan for it first or just build it? Now, people that just take the premise of just building it, they might have to do things where they have to change their mind. They got something wrong. They might have got a measurement wrong. They have to go back and redo it. So that's the link to what we would call technical debt. Technical debt is the thing, the decision you've made because you didn't plan in advance. You just did it and you realize, oh my gosh, I didn't get it right, or it's okay for now, but not good for tomorrow. And I have to go back and tear it up and redo it, which can be very, very costly. So the alternative to model, because modeling essentially you could argue is a planning process. If we choose not to plan and we just build by doing, more power to you. But you will build short-term solutions and iterate and keep changing your mind and tearing things down, building them again, tearing things down, building them again, because eventually you might get it right over time. Now, some people say that's what I want to do because the things I'm delivering in the short term are useful to me. And I'm willing to pay for the technical debt. Other people that say, no, I don't want to do that. I want to have more of a sustainable solution. They're willing to invest up front. So the modeling work is what you do up front to minimize, or not to eliminate, but to minimize the downstream changes because of a lack of understanding or a lack of, I guess, of a lack of understanding of what you really need.
Hmm.
So if you want to kind of build by doing, that's maybe modeling on the fly, if you like, as opposed to modeling up front where you're trying to get it right the first time. Now you can't get it right. Even your models are not going to get right. You can't spend an infinite amount of time. You have to time box it. So
Right.
the point is you will still incur technical debt because you won't have time to do all the modeling you need. You have to time box it. The goal is to mitigate the technical debt or the changes. So rather than having no modeling and a lot of technical debt, you want to have some modeling and mitigate the technical debt. So I think it's really it's a balance point. And you could incur that the cost of modeling is there. That takes time and effort, but the cost of technical debt is there as well, is the rework of things you've already done. So
Hmm.
I think you're looking for how do you balance these two things? Because it's all cost. And how do you balance these two things so we sort of balance out short-term and long-term issues over time. And that's I think where modeling fits in is how much do you need to minimize your technical debt, and then you should sort of seek that out.
That makes a lot of sense. Um, so you mentioned a couple different variations of data modeling there, Mark. Can you explain how does data modeling differ across platforms like relational, NoSQL, and such?
Okay, sure. So I said at a logical level, we try to be independent of those ideas. We try to think about how is the data organized by the real world things that generate it. Now, once you've got that in place, you've got to organize it around the things you care about and their relationships. Then you say, oh, I can go down a relational path or a NoSQL document path. A relational path organizes things with a relational model, which is based on tables. So tables kind of map to the real world objects we talk about. And we have relationships. So really we're designing tables. We're predefining a structure so that data has to fit into that structure. That's called a fixed schema. If you want to go into NoSQL, either documents or graphs are common versions of that. They don't organize their data by tables. They organize data what are called by documents or by graph models. Now, both have flexible flexible structures, and those structures are based on what's called a JSON format or an XML format, which is a way to have keys and values to structure my data. But so we structure things. If we're using like a MongoDB for a NoSQL document database, we would organize things around what's called a document. And a document is like a self-contained set of data to serve a use case. In a graph data model, we'd organize things around connectivity. So you want to look at social networks or financial networks, and you want to see how things flow through the network. You build nodes and links, which are the building blocks of that structure to organize things through a connectivity. So you could have tables, you could have JSON-based documents or JSON-based graph nodes. So these are different things we're producing because the technology now is allowing us to. And that's just a piece of it. There's many other ways to do it too, but that's just to compare sort of the relational versus the NoSQL world.
Fantastic. Well, Mark, it's always a pleasure having you on here. Before I let you go, though, I do want to ask if you can provide maybe a little bit of a synopsis for these folks about the seminar that you'll be teaching for us at TDWI again, December 9th through the 11th, Data Modeling Essentials. Can you take us through a little bit of what that the coursework is? I know it's going to be 3 days, but maybe
Yeah,
you can share some
yeah,
information, please.
sure. So it's a 3-day lineup, and the theme is kind of what I've been talking about here in this discussion is there's different ways to model data depending on the use case. So day one, we'll talk about more of a traditional view of data, which is around relational and dimensional. Now, by traditional, it means they're kind of in a tabular format.
Hmm.
They're based on structured data. And we'll look at a framework, we'll look at ways to organize our thinking around requirements through to building sort of a traditional relational or dimensional approach. The second day is called an advanced data modeling. We'll look at a variety of techniques to look at more architectural views. We'll introduce some concepts of what might be called big data, which is maybe a term that's not as popular as it once was, but it really means unstructured or external data. And that'll set the stage for the third day, which is all about the big data world, which is really NoSQL databases. So we'll go from relational and dimensional, bring in some architectural choices and different sort of miscellaneous topics in an advanced setting, and then we'll get into the third day, which is all about the different kinds of NoSQL databases and what they mean from a data modeler's perspective.
Well, that's excellent. And I'll also mention that if you attend all 3 days of this seminar, you can earn a certificate. And I will also include a link in the description of this episode for folks that are interested in learning more information. I'll take you right to the seminar page on our website. Mark, it's always a pleasure talking with you. I always learn so much when I talk to you. So thank you so much for your time today. And I know I'll probably reach out here shortly to have you on again. But thanks so much, Mark.
Well, I appreciate it, Andrew. Thank you very much, and good day to everybody else. Thanks. Bye.
To subscribe to the Speaking of Data podcast, or to learn more about TDWI's research and training on all things data management and analytics, visit tdwi.org or click the link in the description below. Thanks for tuning in.